Hello and welcome back to Be Pharmawise. In this video, we will be discussing the history of atomic structure. We all know how atom looks like. Like there are protons, there are neutrons, electrons, nucleus, extra nuclear part and all that. But we generally don't think about how this structure of atom must be discovered. So it is a very interesting part to study, and in this video I am going to do the same for you. I'll be telling you the story of how the discovery of atom and subatomic particles was made. Who were the scientists who has discovered various parts of atom, who were the scientists who have contributed a lot in this process, and we will share some interesting points and concepts about the structure of atoms. So if you are interested, keep on watching. So to start from, I will ask you, just have a look around you and see at things. Everything which is around you, which has definite mass and which occupies space, is called as matter. And when we say matter and when we look at these things, how this matter is made up of? This matter is made up of various elements present in the nature, and we have made some elements. At present, there are 118 elements known to mankind, out of which almost 92 are naturally occurring and the rest are synthesized inside a laboratory by scientists, and mostly they are radioactive and they are unstable, so they don't have a very high amount of life. They have a short span of life, but yes, they are there. So there are total 118 elements, and these elements actually make up everything. Okay, so it is not possible that one element makes an entire matter or a substance. So obviously elements combine together. So when we say elements combine together, first we should understand these elements are made up of what. So if you look at the smallest particle of an element, it is an atom. Okay, and each atom of that particular element will be chemically same. Physical properties and chemical properties will be retained in each atom of that particular element. Okay, now these atoms can chemically combine to another atoms, and if similar atoms, for example hydrogen combines with hydrogen, so similar hydrogen atoms, they combine together, then we call such things as molecules. And if two or more different atoms of different elements combine together, for example HOH, so here hydrogen and oxygen, these are two different elements and their atoms are combining together, then we call such things as compounds. So basically molecules and compounds are formed when atoms combine with each other by chemical bonds. If similar atoms combine, we call them molecules. If different atom combines, we call them compounds. So these molecules and compounds are actually forming all these things around us, which we call as matter. So now, as I told you, each atom is the smallest particle of that particular element. It means if I am talking about oxygen, all the atoms of oxygen will be identical, but the atom of nitrogen and the atom of oxygen will be different from each other. So if you have understood this concept, now let's go back to almost 2000 or 2500 years back, and let's start discussing what must have happened in the 18th century when scientists first started to discover these atoms. So let's go back. So the story of Dalton is happening in 18th century, and he was an English scientist, John Dalton. So what Dalton told us is that actually all elements are made up of atoms. Atom is the smallest particle which is indivisible and indestructible. So these two terms are very important when we are talking about the structure of atom given by John Dalton. Indivisible means you cannot divide the atom in any smaller particle, and indestructible means you cannot destruct or destroy the structure of atom. He considered atom as a tiny, small, hard sphere, okay, like this, with no internal structure. Now what does that mean, no internal structure? Have you seen bundi laddu. How the bundi laddu is formed? By joining small parts called as bundis together, we get a bundi laddu, which essentially has an internal structure. But if you look at this hard sphere, tiny hard sphere, it do not have any internal structure. So this is what Dalton expected an atom to look like. Okay, this theory was given by Dalton, this was accepted, it was celebrated, but then certain things started to take place, and in around 19th century, a scientist called as J.J. Thomson, he entered the picture and he started to do some experiments, and we are going to learn what his experiment was. So around 19th century, Thomson started to do one experiment, and the experiment was called as cathode ray tube experiment. Now what is this experiment? What did he do? He just arranged a glass tube which was sealed, and he placed a cathode, which is a negatively charged electrode here, and he placed an anode here. Anode is a positively charged electrode and cathode is a negatively charged electrode. Now these electrodes were made up of certain metals or a particular element. Now he managed to get high voltage current between these two electrodes. Because of that current, because of that high voltage, a rays of particles started from this cathode, and this rays of particles, as they started from cathode, they were termed as cathode rays by Thomson. So these cathode rays were originated from this cathode. Now as the anode has positive charge, they actually went straight away towards the anode, and they were expected to hit this polarographic plate he placed here, a fluorescent plate which will spark or which will detect the when the plate is hit by the particles. Okay, so actually what happened, they were expected to go like this, but he has made a slight modification, and what he did is he placed one more anode here and one more cathode here. Okay, this is the cathode negatively charged and this is the anode positively charged. Now what happened? Here comes the turning point. The particles, instead of going straight in the front, they slightly deflected towards the anode. Now why they must have deflected towards the anode? Obviously because it is a positively charged electrode and the particles are deflecting towards it, it means those particles must be having negative charge over them. Right? So it means when the high voltage was applied, the rays are coming out from this surface of electrode and they are negatively charged. Now Thomson was very happy with this experiment, but he was also curious that what these rays are. So he repeated the same experiment, and this time instead of anode and cathode, he placed different magnets there, and in presence of magnetic field also the rays deflected. It means that Thomson was sure that these rays are charged and they are negatively charged. Through these experiments, he also managed to find the mass to charge ratio of these particles, and then he realized that mass of these particles which are originating from this particular electrode or any electrode for that matter is approximately 2000 times less than a hydrogen atom. Now hydrogen atom was the smallest atom known at that time and even today. So if a particle is originating from particular electrode or element and it has mass so less than even the smallest known atom, it means that particle must be present inside the atom of other elements. So it must be the subatomic particle, and here the discovery of subatomic particle or cathode particle, which was later named as electrons, was made. So electrons were discovered by J.J. Thomson in 19th century through this experiment called as cathode ray tube experiment, and then he discovered the exact weight of electrons, and it is 1 upon 1837 times less or times the weight of hydrogen atom. So it is so negligible, and they are present in almost every element, or not almost, every element. So what he did, how he concluded this, that they are present in every element, he just replaced the material of electrode. Sometimes he used A element, B element, C element, D element. Every time they are being formed and they are having the same mass. So he concluded that negatively charged particles are present inside the atom, and later he named those as electrons. So this is how electrons were discovered. But wait, here comes the tricky point. At that time, Thomson and other scientists were also sure that atom is electrically neutral. Atom do not have any particular charge on it, and Thomson was saying that it has negatively charged subatomic particles. So how is it possible? So Thomson himself thought that if there are negatively charged particles, to counterbalance the charge, there must be presence of positively charged particles also. But he doesn't name those particles, or he doesn't discover those particles. He actually only thought or assumed the presence of positively charged particles inside the atom. Then he thought of an atomic model, and this was the first ever atomic model thought and put forth by a scientist at that time. And he put forth the model which was called as Plum pudding model. Now what is plum pudding? It is a famous English dessert where there is a cake and there is dry fruits. There are dry fruits embedded inside the cake. So he thought the same way that the atom must be the sphere, and where positive charge is actually like placed everywhere, uniformly distributed everywhere. The positively charged particles are distributed everywhere, and the negatively charged electrons are embedded within that positive charge. Or you can also refer this as a soup of positive charge in which negatively charged electrons are floating, or a sea of positive charge in which negatively charged electrons are floating. So this model given by Thomson was the first ever model of atomic structure, which is called as plum pudding model. Now there are multiple developments after this, but we will discuss those developments, the Rutherford's model, the Bohr's model, in the upcoming videos. So if you are not subscribed yet, please consider subscribing and hit the notification bell so that you will get the notification when I post the new video. Thank you so much for watching. Keep watching. Bye bye.